There's basically 7 laws of exponents that you need in order to perform algebra efficiently. What I'm going to do for each one of the 7 laws is I'm going to show you what the law is, and they're all very short. I'm going to show you kind of why it works, and then we'll use it in an example. After we've done all 7, we'll do a couple of examples that combine several laws all together. But, well, let's take a look. There's 2 things that we want to accomplish here in this section. First of all, I want you to know what the 7 laws of exponents are. Some of them you'll see and go, oh, well, yeah, of course that's true. In fact, we've used some of them when we worked with numbers in scientific notation already. But we haven't used all of them. And want you to be able to use those laws to simplify expressions. Those are the 2 things that we want to try and take care of here. Well, the first law we have used before when we were working with numbers in scientific notation, and it's called the law of products. If you've got the same base raised to 2 different powers and you're multiplying them together, then you add the exponents. Now, what was the base that we've done this on? We've used this rule already when we were working with scientific notation. It's just that when we were using it in scientific notation, our base was always 10. Right, and I showed you why this was true one other time. If you have, for example, 10 to the 3rd times 10 squared, wouldn't you agree that that's really 10 times 10 times 10 times 10 times 10? And therefore, you end up with how many factors of 10 here? 5 of them. And so when you have 2 bases, or excuse me, the same base raised to 2 different powers and you want the product, we just add the exponents together. That we've used before. Here's an example. N times n to the 4th times n to the negative 2nd power. That gives us a total value of n to what power? 3. N times n to the 4th is n to the 5th, times n to the negative 2 is n to the 3rd power, and that's all there is to that. Okay? That's one of the most important and most commonly used laws of exponents. Okay? There's one. Well, if you've got a law of products, you got to have a law of quotients. Just wouldn't be right. Well, if you're dividing powers of the same base, we also used this one when we were working with numbers in scientific notation. If you're dividing 2 powers where the base is the same, and again, we did this with a base of 10, then you subtract the exponents. So for example, I showed you an example similar to this back when we were working with scientific notation. 10 to the 4th, 10 times 10 times 10 times 10 divided by 10 to the 3rd, 10 times 10 times 10. Well, what happens to a bunch of those 10s? They cancel out. So in other words, for every 10 that's divided off, it reduces our 10 to the 4th by 1. So we just subtract it, and that leaves us with 10 to the 1, which is really just 10 to the 4 minus 3rd power. Okay? Look familiar? Aaron?
You just write that 10 as 10.
You would not have to write 10 to the 1st up there. I wrote it to see that it's 4 minus 3, but no, you wouldn't need that power of 1 on there. Good question. Yeah, Aaron asked, thank you. Aaron asked, do you need to put that power of 1 on the 10? And you absolutely do not. Good. Well, here's an example. A to the 4th, b to the negative 3rd, over ab to the 5th. Well, tell me, what's our power on a when all is said and done? A to the 3rd, right? So a to the 4th divided by a is a to the 3rd, and b to the negative 3rd over b to the 5th leaves you with b to the negative 8. That's right. Negative 3 minus 5. negative 3 minus 5. So that reduces to a to the third b to the negative eighth. And we could write that another way too, but we'll get to that when we see another rule of exponents. So we've got powers and quotients. Okay, those we've used before. So far so good? All right. Powers, when you have a base to yet another power, the exponents get multiplied. You had a couple of homework problems that dealt with this scenario with powers of 10 back when we were working with scientific notation. The reason this one's true is suppose you have 10 cubed squared. What does that really mean? It means you've got 10 times 10 times 10 times 10 times 10 times 10, right? You're taking 10 cubed and squaring it. Well, that leaves you with how many factors of 10? 10 to the sixth. You take 2 times 3, we get 6 for the exponent. So power to a power, you take the product. That's why it's true. Let's take a look at another example involving variables. xy to the third over z to the negative second power. We're going to raise the whole thing to the fourth power. Well, that x is going to get raised to the fourth power. So what power is on the x right now? It starts out with a 1, but when you multiply it by the 4, which the parentheses is applying here, we've got x to the 1. I'm going to write this in 2 steps. X to the 1 times y to the third over z to the negative second power. That's all to the fourth power. So we're going to have x to the 1 times 4, which is x to the fourth, times y to the 12th, 3 times 4, over z to the negative 8 power. So we've got that simplified. You can. Drew just said, can you bring this z up to the top? You can. In fact, that's one of our rules that's going to allow us to do that. So we will do that later. Right now, we'll leave it the way it is. You're going to do a couple of different types of homework questions. Sometimes the homework questions say that you should get rid of negative exponents. Sometimes they say that you can just leave them. And we're going to do some more examples in a minute to address that specifically. But we're okay with those 4, 12, and negative 8 powers? All right. Power of a product. Now, we kind of applied that one in the example we just did. If you have two numbers that are factors and they're both raised to the power of n, you can apply that power to each factor. Now, why that's true. For example, if we have 2 times 5 squared. What's 2 times 5 squared? It's 100, right? 2 times 5 is 10. Well, we can break that exponent and apply it to each one of these two factors. That's the same as 2 squared times 5 squared. Well, 2 squared is 4. 5 squared is 25, and so sure enough, we get the same value. So if we have an exponent over in parentheses, we can basically distribute that exponent to each one of the bases. And we actually did that in the last example. But let's take a look at another one. Negative 2x to the fourth y, the whole quantity cubed. Well, we're going to raise everything to the third power. So first of all, the negative 2. Make sure to put that in parentheses so that the negative sign sticks with the 2. Negative 2 to the third. Now that's going to become x to what power? 12. And y to the third. But now, what's negative 2 to the third power? Negative 8. Negative 2 times negative 2 times negative 2 is negative 8. X to the 12th, y to the third. And that is our simplified. Now what is this? What's the name of this thing? We'd call this n, this goes back to the first part. Expression, that's right. In fact, it's an expression with how many terms? One term. There's only one thing here grouped together, and so there's one term. Okay. Well, we're just about done already here. We've hit, what, 4 of them? Power of quotient. The same thing applies, basically the exact same rule, but if you've got a fraction raised to some power, you can just apply the exponent to both the numerator and the denominator. Very same principle. The only thing you have to recognize here is that your denominator can't be 0. But that's true with any fraction. So I should note that these are given in this section in the text. So you can, if you have any question, you can look back on those. But let's take a look at this one. Negative 2a squared over b to the negative 4th, all raised to the 3rd power. Okay, well, first of all, let's deal with that negative sign. That negative sign out in front, we can just affiliate that with either the numerator or the denominator, but one or the other. It's usually best to affiliate it with the numerator. So let's just treat it like that. That's a good habit to get into. All right, so now we're going to have negative 2 to the 3rd power times a to the 6th power over b to the negative 12th power. We can simplify that just a pinch. Negative 2 to the 3rd is negative 8 a to the 6th over b to the negative 12th. And it's simplified. Zero exponent. There's certain things that people remember automatically, and this is one rule that nobody ever seems to forget. Anything to the 0th power is 1. Okay? We'll see an example of this one a little bit later. We're just going to state this one. The exception to that is, of course, a base of 0. 0 to the 0th power is not 1. 0 to the 0th power is 0. But that leaves us with one more exponential rule, and we've already touched on it a little bit. The last one we need is this fact. If you have a negative exponent, it basically means we want to take the reciprocal of that exponent. A base with a negative exponent is the same as the reciprocal of the base with a positive exponent. Now, you can say that a lot of different ways, but here's the practical way to remember that. If you want to change the sign of an exponent, you move the base to the other side of the fraction. If it's in the bottom, you move it to the top. That makes the sign positive. If it's in the top, you move it to the bottom. That makes the sign positive. That's the practical way to remember the rule. So a good practice to get into when you want to simplify an expression of this type is to just switch all the variables so that the exponents are all positive. It's easier to think about. You're less likely to make a sign error. So that's what we're going to do. Let's take a look at this example. We want to simplify 3x to the negative 3rd over 2 to the negative 2nd x to the 5th. Okay, so what should we do first? Almost. The 3 stays. Just the x and negative 3rd. They're separate things. Our brain tends to look at that and see that as one thing, but that 3 doesn't have an exponent on it, so the 3 will stay. But the x to the negative 3rd, we're going to drop down to the bottom and make into x cubed. Changes the sign. Okay? What about that 2 to the negative 2? We'll promote that up into the numerator. That becomes 2 to the positive 2. And what about the x to the 5th? Leave it there. Well, then we're home free. 3 times 2 times 2, that gives us a numerator of 12 over x to the, we're using the product rule here, x to the 8th. Now, the homework that you're going to do will ask you to put your answer. There's 2 groups of problems. One says leave all your answers with all positive exponents. We've done that. But another group of questions says, don't leave any fractions in your answer. Use negative exponents instead. So instead of writing this as a fraction, we'd bring that x back up to the top and rewrite it as 12x to the negative 8. Now, what's left in the denominator, really? If that goes up there, there's just a 1 there, and we don't need to write it over 1. So we move that up and change the sign. Now there's no fraction left. So you can either write it as a fraction with positive exponents or avoid the fraction and use negative exponents. Okay. Does that look all right? Okay. We're going to have time for one or two more here. Let's simplify this mess. This one, the instructions are use only positive exponents. Okay, well, the first thing we want to do is clear the parentheses. We're going to distribute those exponents over each factor inside. So this negative 1 will get applied to the 3, and we're left with 3 to the negative 1 power. This becomes x to the third, y to the negative 1, z to the negative 2. All right, we cleared out the top parentheses. Now I'll do the same thing with the denominator. We get z to the negative 6, x to the 15. Okay, now we're going to shuffle around and make everything positive. So let's bump that 3 down below, and it becomes 3 to the positive 1, or just 3. X to the third we'll leave up on top in the numerator. Y to the negative 1 power, let's drop that down below. And z to the negative 2nd power, we'll drop that down below. Now we'll go down to the denominator. Z to the negative 6th. Let's make that positive by putting it up in the numerator. And x to the 15th can stay. And now all we need to do is do any canceling or combining of powers with like bases. So, x to the third over x to the 15th. What are you really left with here? X to the 12th, and where is it? It's down here. So we're left with our x to the third cancels, and we're left with x to the 12th in the denominator. Because you got 15 x's here, 3 x's there, 3 of them will cancel. That leaves you with x to the 5th, or x to the 12th down there. The 3 will stay. So that takes care of our x's and our 3. What about y? Stays in the denominator. And how about z? Yep, and we're left with z to the what? Z to the 4th. That's 6 minus 2. And there it is. It's simplified. No negative exponents. We're good to go.